So today's lesson is going to be on a manometer. And a manometer is a way for us to determine the pressure of a gas. Now, in a manometer, we use mercury because the properties of mercury, it is a liquid and it does have good fluidity, meaning it flows and is able to respond to changes in pressure. And so that makes it a really great substance to use in our manometers. In this first problem, which I've worked out for you, you see it's a closed system. And a closed system means we have gas in the container, but nothing can get out of the container, nothing can get in the container. There's no interaction. So we could determine the pressure of the gas simply based upon the height difference of the mercury. So here's where the mercury starts, here's where the mercury ends, and the difference in height is the pressure of the gas. Now you'll notice in this diagram, it is in centimeters. All right, so we're going to convert centimeters into millimeters using our conversions from Unit 2. And then from there, we can put millimeters on bottom and atmosphere on top. And we can use our standard pressure of 1 atmosphere and 760 millimeters of mercury. And we find that the pressure of the gas is 0.347 atmospheres. So a closed system is pretty straightforward. Now, I do want to give credit to the author of these diagrams. I did not create them, so I do want to give credit where it's due to the author of the diagram. Let's look at the pressure number 2. Now we have an open system, meaning the air outside of the system is pushing down, whereas you also have the gas itself, which is pushing as well. So now we have this system where the gas is, and the atmosphere is kind of interacting. All right, so as one pushes more, the height of the mercury or the atmosphere in the container changes. All right, so if my left hand is the gas and my right hand is the atmosphere, if the atmosphere is pushing greater than the gas, the atmosphere is pushing the gas up toward, or the mercury up towards the gas. If the pressure of the gas is greater than that of the atmosphere, the pressure of the gas is pushing the mercury up toward the atmosphere. And so what do we notice in this problem? We notice that the atmosphere is pushing the mercury toward the gas. So we have this height difference, and if our atmospheric pressure is 760, we can find the pressure of the gas, the total, by doing a subtraction. So 760 minus that 40 is going to give me a gas pressure of 720 millimeters of mercury. So essentially, we're going to be adding or subtracting. If the air pressure gas, if the pressure of the air is greater than the pressure of the gas, then we would have to subtract here because we need a value of a gas that is smaller than 760. If the pressure of the air was less than that of the gas, then we would be adding. Okay, so if we approach it logically and think, okay, what's happening here? Which one is larger? That tells us whether we're going to add or subtract. So let's check out number 3. Looking at my picture, in which direction will the mercury move? All right, so here we go. My pressure of the gas is 104.4, and the air pressure is 99.75. So my gas is larger than my air pressure. So again, using my fingers as our example, the gas is larger, so the gas is going to be pushing down and pushing the mercury up toward the atmosphere. So my mercury is going to move toward the open end. And what would the difference in the height be? All right, so in this case, we have, we know that the gas is going to be greater than that of the air pressure. So what I'm going to have to do here is I'm going to have to subtract these two values out to get a height difference. So when I subtract those two values out, I get a height difference of 4.65 kilopascals. Now, let's say we wanted to put this into millimeters of mercury. Let's say the problem asks, what is the height difference of the mercury in millimeters of mercury? All right, because this is going to give us a good practice. Kilopascals is on top, so we're going to put it on bottom. We can go directly to the millimeters of mercury using our standard pressures of 760 and 101.325 for our kilopascals. And when we plug that into our calculator, we find it to be 34.9 millimeters of mercury. All right, let's do our last problem. A gas container is fitted with a manometer, and the level of mercury is 15 millimeters higher on the open side. Now, using a barometer, we find our atmospheric pressure is 750 millimeters of mercury, and we want to know what the pressure is in atmospheres of the gas. All right. So I'm just going to draw myself a little manometer here real quick, and I'm not the best at drawing. So let me just draw myself a manometer here. I've got my gas. All right, and we're going to start with what do we know? We know that the atmospheric pressure is 750, and we know the height difference is 15 millimeters higher on the open side. So that means I am higher on the open side than I am on the gas side by 15 millimeters of mercury. So what that tells me, the pressure of the gas is greater than that of the atmosphere because my mercury is moving up toward the atmosphere. So if I want the pressure of the gas, I'm going to have to add these two values because my gas is larger than 750. So when I add 750 and that 15, I get a difference of 765 millimeters of mercury. Now, it asked me to put this into atmospheric pressure. So I'm going to put millimeters of mercury on bottom, and I'm going to put atmospheres on top, and I'm going to plug in using my standard values of 1 atmosphere and 760 millimeters of mercury. So when I plug this into my calculator, I end up with 1.01 atmospheres.